One of the very interesting aspects of airline operations is the extended range twin engine operations, generally abbreviated as ETOPS. The content of this presentation was created by two interns, Soumya Saravagi, way back in 2020, and recently updated by Yash Kapshikar. Here is a picture of the screen that I took from a flight from Munich to Mumbai that I undertook recently, flight LH766 by Lufthansa, Airbus A350-900 aircraft. What you can notice in this picture is that the flight path from Munich to Mumbai is not a straight line or even a simple curved line. It is actually turning at various places and it is following a particular path. There are many reasons for this. One reason could be the routes which are existing. The other reason could be the planned route keeping in mind the winds and the weather. But another reason is that if something happens to one engine of a multi-engine aircraft, then there should be enough airports available nearby where the aircraft can deviate and land safely. So, constraints on the flight path can also be created by the availability of alternate airports which can handle the aircraft. Now, what is the need for diversion airports? One example from history is July 2014, when there was a flight with a Boeing 777 aircraft carrying more than 330 passengers and 13 crew members. This took off from Honolulu, the origin, and it was going towards Guam. So, the intended route is shown. The aircraft started its flight, but somewhere in the middle or almost the one third the route, it had a mechanical failure, because of which it had to divert to this Midway Island. It did an emergency landing. Now, another possibility could have been to go to Wake Island, which was the other airport available for it as a diversion. Then there are many examples, as you can see in this particular chart, of various flights in which, due to multiple reasons, there are diversions from the intended route to the routes nearby or on the way. So, what is ETOPS? Imagine there is one airport which is the departure airport shown in the blue dot on the top, and it has to go to an arrival airport again shown as a blue dot in the bottom, and there is a desired straight line route. And let us look at a piston engine aircraft, which was the technology available earlier. Now, this aircraft starts moving, and once it crosses some radius, there is an airport available here which is the adequate airport. Okay. Now, if the failure takes place somewhere here, the aircraft can go to this alternative airport and land there. But if the incident happens at this particular pace, then this airport which is nearby is far away, not within 60 minutes distance. This is also quite far away. So, in case of mechanical failure, there is no airport within 60 minutes flight time. So, the only option the aircraft has is to fly back to the origin. Similarly, there could be other airports in the vicinity. Each of them will have 60-minute flying radius, some overlapping. So, if you want to go from this departure point to this arrival point, you may desire to go along this route, but you cannot, because there may be a situation where you have to divert, and there should be an airport within 16 minutes of flying. So therefore, you have to fly along routes which will be longer than the desired route, but now you are sure that any time if there is an emergency, I do have an alternative airport to land. So now if you have ETOPS clearance, then you do not have to really worry about flying along those 60-minute radius route. You can actually fly along the straight route depending on how much is the ETOPS clearance you have. Okay. So basically the aim of ETOPS is to preclude any instances and to protect the passengers and the aircraft during emergency. Operation of twin engine aircraft, this is so ETOPS was initially provided only for aircraft with two engines and if one engine fails. So as I mentioned, there was a requirement that you should be within 1 hour from an airport where you can divert. This airport could be either over water in the middle of the ocean or over land in the desert, but it should be available. Later on, we started looking at EROPS, which is extended range operations. This is not applicable only to aircraft with two engines, but to even aircraft with more engines. So this is how ETOPS started. So initially, the Federal Aviation Administration came up with a 60-minute rule. Now, many colloquially or in aviation jokes, we can also consider ETOPS as engines turn or passengers swim. Okay. So the first rule was the 60-minute rule, as I explained to you. Now, as the reliability of the engines increased and as the predictability also increased, it was increased to a 120-minute rule, which means within 2 hours of flight time there should be some alternative airport on the route. Further extended to 180 minutes, further extended to beyond 180 minutes. Okay. So now we have ETOPS 270 also. Okay. So now you see the implication. If you have ETOPS 300, okay, then you don't have to worry. If you want to go from this point to this point, you can just fly straight, because anywhere on this route you do have an aircraft, an airport, either destination or origin within 300 minutes plus of flight time. But if you had only 180-minute ETOPS clearance, you would have to go like this in a roundabout manner. Historically, the 60-minute rule was introduced by the FAA way back in 1953 when the piston engines were used to fly the aircraft. It prohibited any aircraft with less than 4 engines to fly on routes which are more than 60 minutes from an adequate airport. So from Gotham City to Metropolis, you cannot fly straight, you have to fly via this particular route. As I said, the main reason was that at that time the engines mostly were the piston engines and they had a lower reliability. So therefore the rule was introduced. Later on, ICAO recommended that it should be amended to 90 minutes rule. In 1964, after about 11 years, the restrictions were removed for aircraft with 3 engines, because earlier it was anything less than 4 engines, but then they were removed for 3 engines and it was then limited only to the twin engine operations. So that's how the name ETOPS came. Then we had a 120-minute rule. This was primarily because of the advent of jet engines like de Havilland Comet, which was a 4-engine aircraft, all 4 jet engines, buried in the route, 2 here and 2 on the other side. Then there were tri or quad jets which dominated the long haul routes until 1980s. DC-10 was one very good example where you have 2 engines on the wing and 1 in the tail. Similarly, Airbus A300, which was the first twin jet made by the Airbus company, they came under the 90-minute ICAO rules since 1976, right from its beginning. In 1980, Lynn Helms from the FAA commented, "It will be a cold day in hell before I let twins fly long haul over water routes." And that's why the rules were introduced. In 1985, the Federal Aviation Administration increased the ETOPS to 120 minutes. The first aircraft to benefit from this was the Boeing 767-200. Subsequently, other rules were also introduced. So, if you have a 120-minute rule, then you can be within a 120-minute flying circle from any origin to any destination. Then we have looked at the 180-minute rule. This was done in 1988. The ETOPS time was extended from 120 to 180. All these extensions were created based on experience, based on a critical study of the statistics of aircraft engine failure. And as the engine reliability more and more increased, there was a case to remove the restrictions. So now with 180 minute in 1988, you had stringent qualifications on the aircraft and on the crew, and we found that around 195% of the earth will be covered if you have a 180 minutes ETOPS clearance. Now this particular rule was allowed or permitted only after an airline has a trouble-free ETOPS 120 for 1 year. So if the airline demonstrates that they could operate without any problem in the ETOPS 120 environment for 1 year, then only they were able to apply for 180. Now when the Boeing 777 was introduced, they requested for ETOPS clearance right in the beginning, but this was not accepted by the Joint Airworthiness Agency of the Europe. Beyond ETOPS 180, so in Feb 15, 2007, FAA extended the conditions further and allowed ETOPS to be for 240 minutes and beyond. Okay, but this is not a blanket approval. This is granted on a case-to-case basis and also only between particular city pairs on which the airline has demonstrated a very good experience of flying 2 years consecutively with not any problem on the ETOPS route, and out of that 1 year or more should be on a ETOPS 240 route with a given aircraft engine combination. Only then you can get the approval of ETOPS 240. The then further improvement or further relaxation was ETOPS 330. The first flight was in 2015 by Boeing 777-200ER, and Airbus A350 XWB was the first aircraft to receive ETOPS 370 on entry itself. So an Airbus A350 XWB was allowed to fly on routes with 370 kilometer radius having an alternative airport right from its inception. ETOPS 207 is 15% operational extension for exceptional cases, and these are the ones which are not subject to beyond 180 minute requirements. Now, what is the effect of ETOPS? Right? The area in which aircraft with 2 engines could operate increased. Right? So, if you have a 60 minutes ETOPS rule, then you are only allowed to fly aircraft along the routes where you have the white color. So, you have to always be within the white color. Okay? You cannot fly a route in the blue color. Okay? Now, if you extend it to 120 minutes, you can notice that the white area increases. It increases over the sea, and the blue areas are only very limited, and presence of an airport like this somewhere again increases the area around it. Okay. Now if you go for 180 minutes, you can see that there is hardly any blue area here and there. So the constraints on the routes is reduced. As I mentioned, ETOPS 180 normally covers around 95% of the Earth's surface. So when you get higher area of operations for twin engine aircraft, you get more distance can be traveled by the aircraft. You can do the flight in less time. You can also consume lesser fuel. It also permits routes which were not possible in the past, direct routes is what I mean, because of the absence of a suitable airport in between. It also came up with new routes between city pairs and increased the frequency on the routes because of higher reliability and gave more flexibility to the airlines to plan their routes as per the requirement. But getting the ETOPS approval is not a straightforward thing. There is a due process involved, and there is a lot of training and lot of equipment related work needed. So let us have a brief glimpse. This is a very detailed topic, and if you look at, there are ICAO guidelines, there are FAA guidelines which run into many pages. But we are going to look only at a general overview. Okay. So many things have to be established before ETOPS approval can be sought by an airline. The first and the most important is how reliable is your propulsion system. After all, the whole idea is to ensure that if one engine of a multi-engine aircraft fails, especially if it is just two engines, you have enough power to reach the alternate airport safely. So how much redundancy is available to you? Do you have only two engines or you have four engines? For example, if you have only one engine, you are just not allowed to fly over sea because you will not be able to divert if the engine fails. All these rules are only for multi-engine aircraft. Design of the APU has to be done very carefully because it will be used for a longer time. Then you have to look at the design of the emergency generator. You have to look at how to minimize the workload of the crew and how to provide system redundancy and ice protection, because many of these routes are going to be over very cold areas. And ultimately it is flight testing that is giving the experience and the knowledge to the airline and confidence to the regulatory bodies to provide the clearance. So you notice there are several requirements from the hydraulic system, from the electrical system, from the pneumatic system. Okay. For example, in the normal case, you can have 3 hydraulic systems with one backup as RAT. If you have one engine shut down, you need the same requirements, but one affected system should be restored by power transfer unit or electro pump. For electrical engines in normal operations, you require 4 generators. Okay, 2 are through engines, 1 through APU, and 1 is standby batteries. Right now, there are some concessions given for various aircraft types. Pneumatic system also, for example, there should be 2 air bleed sources from both the engines in case it is normal operation, but if one engine is shut down, you have only one air bleed source, and that is from the single engine. And similarly, there are certain requirements for pneumatic from Airbus A330. So this is a very interesting picture. So during the ETOPS testing, Boeing 787 Dreamliner was supposed to fly for a very long time. So in the process of doing this flight for ETOPS test, they flew a route which allowed them to paint an aircraft in the sky. The process for type approval looks at the capability of the airline, what is the in-service experience of various people, how many thousand flying hours have been successfully operated by the airline. Then there is a total time to approval based on the commonality between the systems. For example, if you look at the Airbus family, you have engine commonality between 321 and 340, you have system commonality. So all that helps in getting faster approval. Then there is an assessment done by the regulatory bodies, and you look at in-flight shutdown instances. You also look at the judgment of the engineering department, how they have handled this particular process. Finally, every airline has to give a detailed ETOPS capability statement to the regulatory bodies, and based on a scrutiny of that document only the type approval is given. Now, what is the process of certification? So, you have to submit the request 3 months prior and 6 months prior if you want to have an accelerated ETOPS. You have to prove appropriate experience with airframe engine combination. Not every aircraft and every engine combination is permitted for ETOPS. It has to be specific engine aircraft combination. You have to look at the configuration of the aircraft, what are the maintenance practices followed, how much training has been given to the pilots and to the other crew members in during this. And if you want to obtain a faster approval, then you have to apply for TTA, okay, which gives you an option to use your past experience, your existing approvals to get a faster approval. And you have to also mention on what routes you are going to fly when you are asking for the ETOPS clearance. So, here is just a picture about various aspects which are important. You require in-service reliability data. You require a document for operational readiness. You have to look at the aircraft configuration. You have to also look at how you give the training. Then you do a validation flight, just like I showed you for the Boeing Dreamliner, and then all that goes into the ETOPS approval. For example, for maintenance readiness and practices, you have to give all these documents and you have to carry out these various tests to ensure that the aircraft is under fit condition and the chances of in-flight shutdown are reduced. As far as the ETOPS training is concerned, you need to look at the maintenance training, training of the flight crew, the dispatcher, both initial as well as during the line maintenance and the recurrent maintenance. Okay. Now, ETOPS, which was earlier given only for a twin-engine aircraft, has now been modified to LROPS, which is given to aircraft with 3 or 4 engines also. So, ETOPS was earlier only meant for twin-engine aircraft, but now we talk about LROPS. Okay. And there is another interesting variation which is currently being followed, called as the EDTO, or Extended Diversion Time Operations. Okay. So, this was proposed by ICAO in 2017. They replaced ETOPS with EDTO clearance because EDTO is more useful to reflect the scope and applicability of the permission. Okay. So, EDTO includes operations with aircraft with more than 4 engines also, more than 2 engines also, and the routes and guidelines for planes with 2 or more engines are given on routes which are more than 60 nautical miles away from an emergency landing airport. So, here is the statement of the applicability of EDTO. Any operation by an airplane with 2 or more turbine engines where the diversion time to an route alternate aerodrome is more than the threshold time established by the state of the operator, that is where you go for the EDTO. Okay. So, for example, you have these points A and you want to go to point B. Let us draw circles with the 60-minute flight time. Okay. Now, if you draw other circles of 90-minute flight time, you will have larger area. So, when the aircraft goes from A to B, at this point it actually enters the EDTO, and at this point it actually exits the EDTO regime, because from A to this point it is within the 60 nautical mile 1 minute 60 minute, and also from here to here it is within 60 minutes. It is this area where it enters the EDTO. Now, when you have extended operations, you definitely have to have some recovery plan. For example, you should have a requirement if the aircraft has to divert at this point. The airport that you are diverting to should have enough infrastructure. That infrastructure should allow passengers to deboard and be safe. There should be shelter for them, hotels, accommodation, etc. You should have food at that area. You should have facilities for toilets, and you should be able to bring the aircraft and the passengers back to the destination within 48 hours. Okay. This particular requirement came from an example when there is an airport where there was an emergency landing of a Boeing 777 in 2017, and the passengers had to remain on board because there were no enough facilities available to provide them the toilets or the refreshments or the accommodation. So, it has to remain. The temperature here is almost minus 40 degrees and they did not have facilities. Okay. So, with that the requirements came. Now, there are certain very important points on the ETOPS route. Let us have a look at them. There is something called as the EEP, which is the ETOPS entry point. This is the point shown here in the blue color where the aircraft enters the ETOP. Then you have the EXP or the ETOPS exit point, the point where it exits the ETOP, because now it is able to meet its own requirement without the ETOPS. Then there is the ETP or the equal time point, the point from where whether it goes to the destination or comes back to the origin is the same. And then there is a CP or a critical point. Let us look at some of these points in more detail. The ETOPS entry point or the EEP is the specific point on the flight path that begins an ETOPS segment. For example, I showed you here, this is where the ETOPS segment starts. Then you have the ETOPS exit point or the EXP, the point where the aircraft completes an ETOPS segment and goes out of it and goes to the normal regime. Then we have ETP or the equal time point. So, for example, you are at this airport and you are going along this route. When you are here, then whether at this point if the engine fails, you can go back to your origin or you can go to this alternative airport, the time required is same. So, on this route, this particular point will be the ETP, and there will be many more such ETPs. Of course, that depends on whether you have other alternative airports nearby. Okay. Maybe the time taken to go to this or to the other will be the same. So, the ETP is the point of equal flight time between two diversion points, and it is the furthest air mile distance from a pair of suitable airfields. Okay. I mean, from these two airfields, this is the maximum far away you can be. Now, this is only defined for engine failure cases, right? And if all engines are working, then why would you have a requirement to divert? And then I said critical point, the point on the route where if a diversion is needed, the aircraft will require the largest amount of fuel. That is the critical point. So, here is an example of a CP or a critical point. You start from here and this is your route. Now, at this point, you are farthest away from the two alternative airports where you are permitted to go, and hence you are very critical at this point, because before this the fuel required by you will be less, but at this point you will require the maximum amount of fuel if you have to divert. So, these are some important points to be kept in mind. The ETOPS or EDTO is a very fascinating subject, and I would request you to look at more literature and search information on your own to enrich yourself. Thank you so much for your attention.